Welcome to EDU World Space.
If at 3 o'clock a deceased body is found, at the time it was found the temperature was 70 degrees, but an hour later the temperature decreased to 60 degrees, and the person had a normal body temperature of 98.6 degrees at the death, and the ambient temperature was a constant 30 degrees. So we want to calculate the constant proportionality of the situation. So T sub ambient is of the surrounding environment, and we know that it decreased from 70 to 60 degrees after 60 minutes. So we know that it's 60 degrees now when the ambient is 30 degrees. The temperature of the object is the initial temperature 98.6 minus the ambient times e to the negative k, and we know that this took 60 minutes, so we can substitute that for t, and we have to solve for k. Start by subtracting 30 to both sides. We'll get 30 equals 98.6 minus 30. 98.6 minus 30 is 68.6. Then divide both sides by 68.6. Then take the natural log of both sides. That's going to get rid of the exponential base e. And then divide both sides by negative 60 to solve for k. So the natural log of 30 over 68.6 divide negative 60 is 0.0. What do we want to go to here? Doesn't say what to round to. I'll go several decimal places. We'll say 0.01378. Yeah, okay. Estimate the time of death. Okay. If we want to estimate the time of death, then using the formula, we have 30 plus 98.6 minus 30, or 68.6, e to the negative 0.01378 t when where the temperature at the initial time would have been 98.6 degrees. So that's what we want to solve. I'm going to now jump down and start solving. We'll subtract 30 to get 68.6. And then that would equal 68.6 times e to the negative 0.01378 t. Actually, I'm making a mistake here. We don't want to set it equal to 98.6 because that's just going to give us times 0. we want to find the time when it ended up being 70, so that would be 40 because the temperature was found at 3 o'clock and it was 70. So yeah, so we'll subtract it. We get 40 now, divide by 68.6 to both sides. And then take the natural log of both sides to get rid of base e. So do the natural log of 40 over 68.6 equals negative 0.01378t. And you'll divide by negative 0.01378. And will be solved for t. So the natural log of 40 over 68.6 over negative 0.01378. And that would be 39.14. And that would be minutes. So it would take in 39.14 minutes to get to 70 degrees. So if we subtract 39 minutes from 3 o'clock, that would be at 39 minutes, about 2:29 or 2:19, excuse me. 2:21, let's try that. Because if we added 39 minutes to that, then that would be 60 and 3 o'clock. So about 2:21 p.m.